Good. So, yeah, the first question is write a program to compute one of the roots of a polynomial using Newton-Raphson method. No, the all lab 5 due is next Tuesday, so don't worry about it. Okay. So, how many of you tried to learn what this Newton-Raphson method is? How many of you didn't make an attempt even to know what this Newton-Raphson method is? Did anyone wrote a program and see it's working? Okay. Okay, so there are questions like when should you stop, things like that. So, okay, those are kind of bit more technical questions. But my first question is like for example, whatever the root that you are able to get when you put it in the polynomial, are you getting some value like 0.00 something like that? Yeah, there are cases where it doesn't work, etc. But at least like some you may have to work a bit more hard in some cases. But at least the easy cases, I hope that you are able to do it. Is there anyone? No, it's okay. Don't worry. See, there are, as I said, this question in order to do actual convergence, etc. It is bit more technical. So you can say if you substitute the root in the polynomial, if you get three zeros, no 0.000, then think of it as no converged. Does it sound all right? No, if you see, like for example, at some point, if you have f of x where x is the current estimate of the root, okay, so like sorry, I think I can you see this? Instead of chat, I will put it here. So what I'm saying is you start with an initial estimate no, of root as x naught. And then, so you want to find an f of x. Uh, so what's the problem? So find x such that f of x is equal to 0. This is the thing. So you start with an initial estimate of x underscore 0, and then you keep improving it. That's what you do iteratively. X underscore 1, x underscore 2, x underscore 3, so on and so forth you keep. So what I'm saying is at some point, if you find an x underscore n such that f of x underscore n is equal to 0.000, followed by that whatever it may be, maybe you can converge. Does this make sense, guys? Does the termination condition, I'm making the termination condition easy for you. Don't worry too much about, no, it's a, if you go deep, it's many technicalities will come. So the session is being recorded tonight. So are you, first one is termination condition. I hope you're all with me. Yes or no? You're all, I hope you're all with me. Yeah, so polynomial, so let's say the polynomial is 2 times x square plus 3 times x plus 1. So the polynomial, you just enter the coefficients of the polynomial. That's all. You take the degree of the polynomial and you take the coefficients of the polynomial either in the increasing order or decreasing order of the degrees. That's okay. If you want to take the coefficient and take the power of the polynomial, that's also good. No problem. But the only thing that you should avoid is don't try to read the polynomial like this. Like how I have written on line 11. If you try to write it like that, then you have to parse it and no. You can do it. So Kishore can do it. So, but others we can just get the coefficients in some form. Coefficients of the degrees we can. Yeah, guys, don't sweat it out on trying to read it and then parse it, etc. This is just unnecessarily, it makes it painful for you. Make your life easy. Just read the coefficients of the polynomial in some fashion. That's all. No Python. This is all C. We have to generalize, just not for degree 2. Yeah, for graphs we can do. How do we code the termination 0.000? You check now, and it's how do you do? Let's say the current estimate is, so you just compute f of xn, and then you kind of check, like if absolute value of f of underscore. See, today I'm not able to use something like minus 0.0001 difference, no? And check if it is greater than. I don't know whether this is how you should do it. Maybe something like that it may work. Yeah. So Vikram has Aditya has some suggestion, but it may not converge. Varshita, if you just keep. You don't worry about local minimas. You just that's all right. You don't. You say you kind of. Okay. So if you're all good on this one, shall I move on to the next question? You understood any clarifications you need on this? Anirudh Kaushik has this nice thing, no? If it is less than, yeah, something like if it is less than 0.001 or, yeah, there are many ways to check that. Please go ahead and check it. So those of you who didn't yet start, you should start now and solve this problem. This is a fun problem. How many of you enjoyed solving this problem? This is a fun problem to solve, actually. Very nice. Uh, Boring, huh, Mugundan? See, actually, one thing that you should try to do is if you can store all these x0, x2, x1, x2, x3 in a file, and also the polynomial, you can plot it and then see how you are converging on the curve. No, you don't have to submit lab 5 on OJ. Don't worry about it, guys. Okay. Uh, so I think if you're all doing good, so but one thing I would suggest is those of you who have got bit more time and enthusiasm, energy, you can plot the graph and the x0, x1, x2 on the graph and see how you are moving towards the route. It is plausible if you use Python or some kind of tool. If you use it, is possible. Okay, so give it a try. So now let's move on to the next question. Next question is, write a program to throw a dice which can generate one of the 6 faces from 1 to 6 uniformly at random. Throw the dice a million times, compute the histogram, plot the histogram, and check how far is it from histogram. Okay, so how many of you finished this problem? This is just possibly, few, it's hardly, you just write a loop and you do make a call to rand, you do %6 and you are done. And you increment the corresponding counter. How to transfer the data? So let me do one thing. In order to transfer the data, yeah, why should I even do this? No? Let me go here. So let's start with our pun program. See, this is pun.c. No? So gcc pun.c. If you execute this program, you see it on the screen. If you want it to be redirected to the output to be redirected to some file, you just do greater than option. That's all. So pun.out, that's it. So cat pun.out. So whatever you want to print, you print on the screen and you just use this greater than operator. That's it. Done. Cat is a command. Cat is a cat. Okay. Thank you, Shubh Agarwal. So cat means, yeah, you print it on the screen and that's it. So do you know how to, now the TS may will show you how to, in the lab session, they can, they will show you. But anyway, so you can redirect the output of your program to a file using this greater than. Good, exactly as I think it. Okay, guys, let's move on to the next question. You should, if any questions in this record, you should. I think some of you are all in good mood today. I'm happy for you. Okay. So any clarifications you need on question 2? Question 2, you are good, na? Good. Okay, let's keep going. Krishna has some doubt. Tell me, Krishna, what's up? You use it sleep for what? You use it sleep for seeding. So if you sleep for some time and wake up, the world looks random for you.
Sir, can you hear me?
Yes, yes.
No, sir, no. I used a strand and time void, sir, time null. And
Okay, but where is sleep coming?
I mean, if I run it multiple times in the same second, we'll get the same output, no, sir. So
It's okay. Not like you run it immediately. No? If you run it even with a bit of difference, it will be, you don't get the same sleep. Don't use sleep.
I mean, I wanted to ask what is the alternative for generating random numbers?
Um,
Do we use the program which you showed earlier sometime using ABC and percent and I mean
no,
some
no, no. See, I don't know. Seeding itself is a very complex process, but don't use sleep. For the time being, let's make your life easy. Just use time null.
sir, but when I use that and I put 10,000 outputs, I got all of them as one, sir.
No, then
So
you are doing something wrong then.
okay,
For sure. It cannot be the case.
okay,
Can you show your program maybe to the TA, because you could be doing something wrong.
okay, sir.
Uh, you could be doing something wrong, because of that you are getting it. Okay.
Okay, sir. I mean, when I'm using sleep,
Maybe
I'll
you
get the.
can show the code to me or to the TA or to your classmates, and we will, what is the issue, we can figure that out.
Okay, okay, sir.
Okay.
Thank you, sir.
All right, guys. Okay. So the next question is, write a program to throw two six-faced dice. Sum the face values of the two dice, which will be some value. Yeah, it will be some value between 2 to 12. Throw the two dice a million times and compute the histogram. Plot the histogram and check how far is it from theoretical distribution. How many of you did it? Is it good? You're all. So here I have one interesting question which I kind of studied a long time back. Um, what is that? In question 3, while calculating the deviation, should you also consider the probability of getting the numbers, for example? What do you mean by 2 is only 1 plus 1? Yeah, that's 4 is 3 plus 1, or you should, all those possibilities. Yeah, that's true. So, yeah, next thing is, so here I have one interesting question for you. If you want to throw, no, roll the dice one, so there are two things, there are two ways of doing it. Okay, so let's, one is you do SRAND, no, you do some seeding process here. Yeah, so maybe, okay, so maybe one simple way of doing it is, of course, rand percent 6. Oh yeah, you can use. Is this how you did? So approximately. Approximately may have done. So unfortunately, today I don't have my, anyway, I don't want to repeat it again and again. But let's see. But like in practice, they say that if you take two random numbers, you are extracting random numbers from the same sequence. Na? Sometimes they say it is better to use two different random number generators for the two different, yeah, from the same, instead of some from the same seed, maybe you can use two different random number generators and with two different seeds. Uh, they say that, but I'm not. So when you are doing later on, when you, yeah, in this particular using rand, we don't know how to do that, but the lcg.c code, we have it. You just use that code and you can do that. So you can use two different random number generators. um, yeah, good question, Lakshmanan. So maybe in order to do that, you may want to use rand 1 and rand 2. This is one way of, but this is not the right way to do it. But what happens is, those of you who know Python or C++, when you can create a random number generator object, you can have two different random number generator objects with their own internal seeds. Oh, ran underscore 12. Hey, Parth, you are generating, in which case, if you do this one, you are generating a random number between 0 to 12. You are generating yeah, so that's not the right way to that's not the right way to do it. So you have to do like this on line 16. So and then you say dice 1 plus dice 2 is the sum. No, so don't worry about it, guys. You see, don't try to do what I am trying to make a point here. I am trying to make a point here. There are, for the random number problem, there are two strategies. Strategy one is the simple strategy where, you have so dice 1 is equal to, so go with strategy 1, don't complicate your life, no problem, perfectly fine. But what I'm saying is, in many times in practice, they say sometimes it matters that if we may want to use two different random number streams when you want to generate two different things. Are you all with me here? Did you understand the two strategies? Shall we go ahead and move to the next problem? Okay. Yeah, so how about problem 4? How many of you solved problem 4? It's my favorite problem, actually. Again, I would like you to print the sequence of pi's and then so since and then plot it, and then you see it keeps oscillating and then it converges. Okay. So what is your strategy to do? So problem 4 is a fun problem. I think if you have is there anyone who has trouble with problem 4? How to do problem 4? And I think you should try it out. Think about it, and you have all the background required to solve the problem 4. Not an issue at all. Yeah, they call it as Monte Carlo method, I guess. So what is your strategy? You have to generate a random number which falls within the square, and then you check if it falls within the circle too. And
I'll be right back.
Sorry? So good question. So how to generate random? Yeah, you got it. You use DRAND 48. So you read man DRAND 48. So man DRAND 48, it generates a random number between 0 and 1. I think in order to help Mukundan or deal with Mukundan, we should have an OJ for this. He's doing everything in Python. Mukundan, do everything in C, man. Yeah, you can do even RANMAX. What Kishore did is also all right, no problem. So yeah, graphing you can use. So the graphing you can use for graph purposes, you can plot it, you can use Python, no problem. If you are. Which function you can't find in any section of the manual? See, what I did is this, okay. Other day I thought, I was also looking for the same. So what did I do? Man minus k rand I did. When I did man minus k rand, then I got all these whichever man pages has rand, they came up. And then I think I did minus man minus 3 rand or something like that. Yeah. Man minus 3 random. No, something. Yeah. So anyway, yeah, man 3. Yeah, okay. Man 3 rand. Yeah. So sran ran underscore r unseeded. Yeah. So anyway, if you do man minus k rand, you can see different kind of random functions that are available. And also if you go at the end, no, so you will see, you should know how to read the man pages. When you do man rand and you go read this man page, at the end of, you should always look at the end of the man page, because at the end of the man page, it suggests what are the other things you should be looking at. Like for example, here there is DRAN 48, and then I did a man DRAN 48, and then I got it. So man pages. Okay, so you figure this out. Shall I move on? So next Tuesday is a kind of hard deadline for this. So data for 5 and 6 is already given. Yeah. So what is the problem for data for 5? So you just, this is easy, right? The problem 5a is easy now. How many of you did problem 5a? Finding the mean. Yeah, you should try 5 for a sequence of numbers. Problem 5a is problem a is you just have to compute the mean and variance. So it's easy. You just have to write a loop to compute the summation, and then you divide it by n and you get the variance and mean and variance. But the challenge problem is, let's say, can you compute the variance also? Yeah, write a program to, yeah, this is the challenge question. Write a program to compute the mean using constant amount of memory. Here, constant amount means anything which is not a function of the input sequence length. Can you compute the mean using constant amount of memory? Can you compute the mean using constant amount of memory? Right? How about computing the variance using constant amount of memory? Can you compute variance using constant amount of memory? Yes or no? But I think there is one interesting thing I didn't make it here. That is, if you are allowed to make only one pass on the data, if you are allowed to make only one pass on the data, that is how one. So the easiest way to compute variance using constant amount of memory is you read x1 to xn, and then you compute the mean. You make another pass on the data, and then since you already know the mean, you do x minus mu whole square and you do the accumulation. Yes, right? Are you all with me here? You first compute mean, and then in first pass, in the second pass, you compute variance. Okay, so I think some of you have a. Let's all take one step back. First question is, can you compute mean in single pass using constant memory? So computing mean, single pass on the data, constant memory. Yes or no? Yes or no for this one? Yes, right? No, you don't need to store the array. No, you just read it, and then let's say if it is in one of the programs, if you recall, we did a redirection from a file. Do you recall that? We are not storing it in an array. Do you recall that program? So we just do a scanf. We don't store it in an array. We just redirect it from a file. Okay, so there we need constant memory only. So now the second question is variance single pass constant memory. How many of you say yes? Oh man, lots of yeses, huh? How do you do it? Mean of squares is equal to squares of mean. No, no, no. If you expand the variance formula, what do you get? Mean will come out, na? If you expand the variance formula, x square plus mu square minus 2 mu xi. But how do you don't have mean, right? Where do you get the mean? Outside the loop, Kishore, what are you? I didn't get you. I am not able to see how you can compute it in one pass. But you need to know mu, na? So that is the thing. So in one pass, so variance in two passes, my answer is this. This is not possible, but this is all right. Two pass, constant memory is good. Are you with me here? How is it possible in single pass? Xi it's discrete, means it's real numbers. Yeah, you can unmute. It's all unmuted. I didn't.
Good afternoon, sir.
Yeah, good
So,
afternoon.
so if you expand the variance formula, you'll see that variance is equal to the mean of the squares of the values minus the square of the mean. So
But how do you compute? Oh, minus the square of the mean.
Sir, I can't hear you.
You cannot hear me.
Yeah, yes,
X
now
square. Hey, but you have x square minus 2 mu xi, right?
yes, sir. X square minus 2 mu xi plus mu square.
Okay.
Then first term is the mean of the square.
Oh, okay. So you keep adding x square and then mean minus mu. So you have xi and then oh, okay, understood. Got it.
Yeah, so you can parallelly compute sum of x square and sum of x. And at
Ah,
the
got
end,
it, got
find
it.
mean and
Understood.
subtract.
Thank you, thank you, thank you. Yeah, very good. I missed that point. Yeah. So x square minus 2 mu xi. Okay. Then I'm going to make your life harder. Maybe I will make it xi minus mu whole cube. Does it work? Okay, okay. Before I make it harder for you, so what you said is right. Yeah. That is, so I think this is what I missed out, guys. So it's very nice point. So essentially xi minus, I'll just use mu square is equal to, again I just use xi for the sake of simplicity, xi square minus, okay, I have to use, understood, since sigma xi square annotations are easier. Okay. No, we can use n, but you cannot use an array of size n. And, okay. Okay, understood. I think it is possible. Then the challenge problem is kind of got boring for you. Then maybe, how about the challenge problem C? You wouldn't understand Abhinav's method. So all you have to do is expand that summation. What is xi minus mu square? It is xi square plus mu square minus 2 mu xi. You take the summation inside that expression, then you are good. And part C, similar to the writer program, which computes the percentage of numbers which fall in the range. Yeah, so part C, guys. So how are you doing on part C? So is it possible for us to do it in uh, one iteration? In one iteration, what do we do? If we know, if you're giving two passes, is it possible? Let me ask this question. Two passes, it is possible. If you want to do in one pass, what we do is we have a current estimate of mean which we keep improving. So by using that, we get an estimate of it. Does it make sense? What is the current estimate of mean when we read the ith data item? It is sigma x1 to xi divided by I. That is the current estimate of the mean. So as the value of I increases, like for example, our estimate of mean keeps increasing. It's okay, but it's kind of, these are the tricks. If the, let's say if the data is has some kind of good uniform distribution or something like that, then it's all right. Yeah. Or Gaussian or distribution. But you understood the approach, right? What I want you to understand from this challenge problem is, when as you keep going, you, based on the data that you have seen, you keep improving the estimate of some parameter. If it's not a Gaussian curve distribution, maybe if some distributions it works, some distributions it may not work, right? So that's okay. Two passes will, and why are we so worried about this two passes thing? Exactly. So Kishore got it. So there are two things. Let's say if you're working on 1 terabyte of data, if you're working on 1 terabyte of data, there are two problems here. You cannot store the whole 1 terabyte of data on your memory. You cannot have an array which can hold 1 terabyte of data if you have 4 GB memory or 3 GB memory or whatever it is. So that is number one. Since you cannot store the whole data, computing mean variance the way usually we do on small data sets is not possible. So the second approach is you make two passes on the data. In the first pass, you compute the mean. In the second pass, you do some other, whatever the other things that we are planning to do, that you can do in the second pass. But making one more pass on the data is extremely expensive, because when you keep reading data, in order to read 1 terabyte of data, it may take maybe half an hour of time. So if you want to make 2 passes, it will take 1 hour to do the computation. Are you with me here on this problem? So in order to solve this problem, there is an area of algorithms which is called as streaming algorithms. Algorithms on streaming data. That's true, Lakshmanan. If it's it may not work if it's a bad, data distribution is not good. But I'm just trying to give you some kind of glimpse into this area, this kind of problems, where the data is so huge that you cannot keep it in the memory. I want all of you to be in this, okay? Number one, there is a problem on your hand where the data is so large that you cannot keep the whole data in the memory. So you have to do your computation using the small amount of RAM that is given to you. Are you with me on this use case, particular use case? First case. There's a whole lot of, the size of the data is so large that it cannot fit into the memory. That's the issue. At the same time, if you want to keep going and visiting the disk, it's a problem. So you want to minimize the number of times you want to read your file. So because of that's where whether you can do the computation in 1 pass or 2 passes becomes an issue. Are you all with me? The second case is you don't want to make multiple passes on the data, because the data is so large. Reading 1 terabyte of data 2 times, it takes a lot of time. So you want to do your computation using only in a single pass if possible. Exactly. So what Kishore is mentioning in the chat box is very apt. There are other cases where you want to, this kind of thing may also come in. Let's say, like there are what are called as Internet of Things and devices on the edge, etc., where a sensor keeps reading, some kind of temperature information or something like that. So the sensor node doesn't have a lot of memory there. In which case, based on so at some point it has to discard the data, the previous data that it has seen. So it gets to see the data only once. Okay. So again, the sensor data, if it is trying to estimate the mean temperature, variance, things like that, there also these kinds of problems will come in. Yes, STD in STDO, there are also streams. That's true. Are you with me on the sensors IoT example, that if you have a small device with a very small amount of memory, it keeps reading data from the environment, but it doesn't have infinite amount of memory on it. So after some point, it has to drop off some data which it has read. Again, in those cases also, this kind of challenges you may face. Yes, Lakshman, that's true. There are ways to do it, but one way of doing it is this. It is the particular way Vivek is mentioning. It is called as moving window mean. But there are different kinds of moving windows possible, but it's based on the available memory. Right, exactly. Are you all with me on problem 5? Do you understand the spirit of inquiry required behind problem 5? I don't know how to get how we could take. So Shashwat, we will in couple of classes, not in couple of classes, maybe yeah, in 2-3 classes, I will teach you how to read files. Then it becomes easy for you. No, using the current estimate of the range. So what happens is, see in the problem number C, this is what I am thinking. That's a challenge problem, guys. You should think. Okay, so this is not like, that's why it's a challenge problem. What I'm saying is, so there is an estimate of mean. Initial estimate of mean is, let's say, mu underscore naught. Okay, so let's say the first data item that you see is x1. When the first data item that you see is x1, so the estimate of mean is mu naught. Mu naught is equal to maybe x underscore 1. And then after that, you see x2. When you see x2, you should improve your estimate of the current mean. Okay, so update, so mean 1 is equal to update mean. So based on mu naught comma x underscore 2. This is how we would like to update the mean. So in general, when you after seeing xi, so you need to update the current estimate of mean, update mean. Are you seeing what I'm trying to get to you here? X underscore I. Are you with me on line 46 to line 49? What is happening? So this is what yeah. So wait. So once we have the current estimate of the mean, whether the value is falling in that range or not, it depends on the current estimate of the mean. Let's say when you see after line 52 as a sub, after you update the estimate, you kind of check if 0 point whatever that condition. What is a 0 point? Yeah. So you want to check 1 point. What is this? Yeah. You want to check 0.8 mu underscore I times I less than or equal to x underscore I is less than or equal to 1.2 times mu underscore I. If that is the case, you kind of increment it. I hope you're all with me on this particular thing from line 45 to line 54. If you're all with me, I will move on to the next problem. We are not modifying the mean. So you have to, this is a challenge problem. I want you to think about this. You want to improve the current estimate of the mean. How do you, so what is this update mean function? How does it look like? I want you to think about it. I don't want to give away the answer because I already gave a lot of hints. That's a challenge problem. I want you to think about it. Is it all right? Is it a fair thing? Because there's lots of hints are there. All you need to do is you need to figure out what does this update mean. Yeah, so it's okay. So if you want to see the number of data points that you have seen, that is I. Like for example, in this particular case, I is equal to 2. So the number of data points you have to do something like that. Okay, this is the rough idea I'm giving. You are right, Mihir. Yeah. No, you don't have to use an array. I just used x1, x2 to index the variables. You don't need to use an array. I'm not saying this will work in all the cases. I'm saying, can you use this approach to do something? Okay. I'm sure there could be cases or many cases where depending upon the distribution and how the data is coming, things could go bad for you. Okay, I'm not giving you any more hints because I want you to think about it. What I'm trying to tell you is start with an estimate of mean, keep improving the estimate of mean as you keep seeing more and more data. And then at every point, you see whether the new data item that you have seen falls within that interval or not. If it falls within that interval, you increment the count. This is the algorithm. Is it all right? Shall I go ahead, or I think in this problem, even if you're a bit lost, I'm fine with it because I want you to think about it. Okay, that's the reason it's a challenge problem. Okay. Good question. So, all right. So, last question, question number 6 is, yeah. So, how many of you tried this one? Question number 6. So, this is again an interesting problem, in my opinion. So, you want to generate a sequence of zeros and ones. So you have to generate a sequence of zeros and ones. One approach is use the linear congruential generator, LCG generator, and then generate, so random number 0, random number, sorry, x underscore 1, x underscore 2, x underscore 3. You keep generating using the rand function, and then you take percent of 2, percent 2, and then you get 0, 1, maybe 1, again 0, maybe again 1, again 0, like that. So essentially x1 to x0, x1, x2, x3, x4, they are generated using a rand function, and then you take mod 2. You get a, so you get either 0 or 1. This approach is clear, right? How you can use a rand function and just take a mod 2 and you get a 0 and 1, and hopefully we will get a uniform random thing. Are you with me here on this one, the first part? You're all good here? Okay. The second part is, the second part is, you want to, this is what we have to do, right? Compute the probability. Yeah, it's good. So, and then what you want to do is, the second approach is you generate the first 128 bits using some approach, like for example, the approach given by Frame, you just do rand %2 for 128 times, the first 128 bits will be generated. Don't worry about optimization here. So if you want to use a, bool array, or if you want to use bits, you don't worry about it too much, okay? It's not the char or bool, it will just be the same. It's not going to change much here. And then you generate this stream, xi is equal to xi minus 1, exclusive or with x. You use this formula, the formula that is here, and you do it. That is exclusive OR, which we have discussed in the class. One exclusive OR with 0 is 1, one exclusive OR with 1 is 0. Then, so like that. That's an exclusive OR function. Thank you, Karsh. I'll just take 5 minutes and then I will drop off.
Okay, sir. Thanks.
So here, this approach is, you want to, this question B, it is very interesting, because in order to know truly, like for example, let's say the sequence that you get is something like this. Okay, the sequence you get is 0, 0, 0, 0 followed by all ones. Is this, if you look at the probability with which 0 and 1s come, they are uniformly distributed, but is it random? Is it random? Is it a random distribution? It's not random distribution. And then let's say if I say it is something like 1 0 1 0 1 0, is this a random distribution? So if you see 1, then you can predict it is going to be 0. So if you use a random number generator like this, like for example, OTP generation or something like that, then what happens is, then you know what could be the OTP, and you can kind of hack the system and things like that. So in order to, what is truly random is, if you see a bit pattern, whatever pattern, sorry, this is like, so you have seen this sequence, and then, so good question. So you have seen this sequence, and then having seen this sequence so far, you don't have any clue what will be the next bit will be. Is it going to be 0 or is it going to be 1? If the probability with which this sequence, the next bit is equal to 0 or 1, if it is equiprobable, given that we know the whole history of the sequence, then that is a truly random sequence. That will be great. Okay, I'm kind of giving an approximate story here. In order to kind of capture this thing, what we are trying to do is, there are many tests that we can do. Here, what we are trying to do is, what is, if we know the current bit is equal to 0, what is the probability that the next bit is equal to 0? Okay. And if we know the current bit is equal to 1, what is the probability that the next bit is equal to 0? So, yeah, so what happens is, this is fun thing, because if this is the case, did anyone compute and what is the probability you got here? Can someone tell me, like in question B, for the sequence that you tried out, what is the probability? Great, great. So that is nice. That means, no, by knowing the current bit, you will not be able to say what is the next bit. And this kind of stuff is useful for encryption. Like for example, let's say you want to send a file. What you want, in order to send a file secretly, you want to, you want to encrypt it. One way of encrypting it is, you start with a seed and generate a sequence of bits whose length is equal to the length of the file, and then you exclusive OR the file with that bits, and you get encrypted data. And the other person will be able to extract or decrypt it only if he also knows the seed function. Argue with me on this encryption strategy, that the two parties, they share the secret that they share is the seed. If both of them have the same seed, the sender will encrypt it using the exclusive OR function, and the receiver will decrypt it using the exclusive OR function by generating the same pseudo random sequence. How many of you are with me on this one? That this idea that you send the secret is the seed, and the both parties will share the seed. You may send that seed now by using uh, some other channel, which is some other secure channel. The encryption method is very simple. So maybe you take that 128 bits, that is the secret that you can somehow generate, and that secret you share it with your receiver. And then so you generate a pseudo random sequence basic of bits based on your seed, and then you use the encryption mechanism that is given in part C. And on the receiver side, they can decrypt it by exclusive ORing the message with the same pseudo random generator. So maybe I will explain this one more time, on some other class. Like for example, what I'm trying to tell is, if you want to send B and you encrypt it using some encryption, some sequence E, some bit E. This is exclusive OR actually. So this is the receiver bit. The receiver gets R is the bit received, and S is the bit that is being sent, and E is the that is the secret that E can be 0 or 1 with equal probability. So by knowing, if let's say if S is equal to, if this is equal to 1, then you will not know whether S is equal to 0 or 1, because E is equal to 0 or 1 with probability half. And what is a decryption strategy? The decryption strategy is nothing but you take R and then you exclusive OR it with I think if some of you are lost, it's okay. I will get back to you. I will explain it some other day. Okay, maybe in tomorrow's lecture, I will revisit it one more time. But this is the idea. So okay, guys. So problem 6 I will explain again later. Not problem 6. The problem C part of 6C I will explain maybe in tomorrow's class. Yeah, probably in tomorrow's class. What else? I wanted to make one more remark here. Yeah, this is what. So someone, Kishore was asking me the other day on pseudo-random number generators. There is a whole book of pseudo-random number generators. There are multiple books. There are books written on pseudo-random number generators. And there are multiple tests that we do in order to check whether a sequence is really pseudo-random sequence or not. But let's see. I want you to, take a look at this pseudo-random. Are you able to see this? These are all different sequences, different generators. The generator that we have seen is linear congruential generator is what we have seen. But there is something called as, for example, quadratic congruential generator 1, where the way we generate xi plus 1 from xi is you take xi and square it, and you take modulo p, where p is a 512 bit prime number. You start with an initial 512 bit seed x0, and then you keep doing this operator. This is what is called as a quadratic congruential generator. Does this make sense, quadratic congruential generator? Are you with me here? So if I gave you this problem, if I ask you to come up with a quadratic congruential generator, what would be the problem you will be facing in writing code for this? What would be the problem you would be facing to write code for quadratic congruential generator? So one question is suitable prime, squaring 512-bit prime, creating the 512-bit prime, overflows, all are very good answers. Even the long integer or long integer, I don't know, it would be of maximum of 8 bits. And 8 bits means 64 bits. But you want to work with 512-bit integer. How can we work with 512-bit integer when the language supports only 64-bit integers at max? Use Java. Brilliant, man. Well, AVX 512, but you still need to represent. Good question, Kishore. So maybe we have to check it. So you have to define your own custom data types, which are of length 512 bits, and work with them. Use digit arrays and define your own specification of big int. Exactly, Pratyaksh got it. Okay, so you need to write your own code for handling integers of length 512 bits or 1024 bits or 128 bits, because the default machine the machine or the language doesn't have support for integers of that length. Are you with me on this problem? Because this is this is a very fun problem. Maybe I will just give this problem so that you'll understand how things work. Are you all with me here on this one? I want you to see the problem. You don't need to get to the solution, but I want you to see the problem. In order to be able to realize the quadratic congruential generator, uh, uh, so in order to be able to generate the quadratic congruential generator, we need to be able to do arithmetic on integers of length 512 bits. That's a very, that means that you cannot just use regular addition operation, etc., because they cannot handle data of this big data. So you have to write your own libraries, functions to deal with this arithmetic. In general, the whole area of cryptography, where we do lots of digital signatures, many things that you will learn later on, they kind of work with data items which usually of length 512 bits, 1024 bits, etc. So you have to need to, so that's the reason why cryptography people, they will write their own libraries, because the default data types, they are not sufficient for them. So shall we take a break for today? I think that's all I have for you. I will give you quadratic congruential generator as a homework, as challenge problem in the next session. And I think many of you are not happy about the discussion on this particular problem, 6C. I will revisit it and make it uh, easy for you. Okay, and we'll discuss it, and then so that everyone gets good clarity on that problem. So now what you have to do is start working on the homeworks. TS will show you how to plot graphs, things, etc., in your respective lab sessions. So please join them. Okay.
Hello,
So,
sir.
yeah.
Cut this side. So we are taking common session in this link only.
Oh, okay. Then I will make you co-host, and then
Yeah.
shall I log out? Is it all right?
Yes, sir. Yes, sir.
Okay, then great. Fantastic. So all of you stay here. So TS are doing it here. I'm not even making myself host. You are the host, Karsh. So now
Okay, sir.
I'm logging out. So all of you stay back, guys. So yeah, TS will help you out in this problem set. Okay. Bye.
So Dhruv, can you hear me?
Yeah, yes.
You can take over. So,
Can you make me co-host?
yeah, just a second. I made you.
Hello? Yeah, can you all see my screen?
Yes, sir, we can.
Yeah. So for this lab, you will have to plot a line and a histogram. So for histogram, yeah. So for dice one, suppose this is a sample output that you got, and you have to just print the value. You have to create a comma separated file, which is called a CSV file for this. Now for the CSV file, you will have to print the dice number and then the value in a comma separated fashion like this, and then just compile this. You will get the output of this form. So you will just have to redirect the output to a CSV file. And now go to Google Sheets. Here just you have to import, upload, and just upload the created CSV file. Yeah, nothing to change here. So the values will be here, then just insert chart. It would automatically create a histogram. So for histogram, that's all you have to do. Now
So,
if you want to plot a function,
so
let's say,
guys, you can just like check on your like
yeah,
terminal also. All you have to do is like store your output in a CSV file. So for that, how it works is you have to store output in a comma separated one, in a comma separated way. Instead of space separated output, you have to give the output in the printf as comma separated. So how what it will do is it will store the all the values in a table format in the Google Sheets. So you can follow the instructions. Just open Google Sheets and just import the CSV file, and it's very easy then.
yeah, let's say you want to plot the square function. You just print the square function, just replace the I into I by any function you want, and then just,
And yes, if someone has done from Python and Matplotlib,
yeah,
it's okay. You can do from that also. But Google Sheets is the most easiest way currently. So that's why.
yeah, just select and it would automatically create a chart for you.
Once we will tell you the format for the output, etc.
Yeah, so any doubts? Anyone?
Guys, are you following it?
Can you just show the graph thing again?
Just show the graph thing through how to like make a graph.
Just import, just select the CSV file. So you don't have to change anything here. Convert text to numbers, yes, and separator type it will automatically detect. The data would
So
be
basically,
separated and
once
then,
your data comes in the Excel sheet,
yeah,
then what you have to do is insert and then chart. So accordingly, you can select the chart type like line chart or anything else.
you can change the labels here.
So this is the most easiest way of like currently doing it.
You can change like,
So you can like label the axis and like you can scale down the axis, etc.
yes.
And the color, etc. Thing. You can just do the modifications in the customized thing. I think that's very basic thing. I think all of you should get it. Can you show the CSV command again, please? You just have to like redirect it to the CSV file.
Yeah.
That's it.
You just have to print in comma
Yeah,
separate.
Krishna, you can like do it in any format. Yeah. So I hope all of you have like done the 4 questions in that problem set. And for plotting them, this is the thing which you have to do. So just try doing them like. Is there anything else, bro?
No, that's all.
So guys, have you like are you following it? So like regarding
Libre, The platform doesn't matter. You can do
There
it.
can be more than one way of doing this.
Yeah.
So you just have to like do these problems. I think guess there were 4 problems, right? So just do the 4 problems and like just plot them. And you can if you know any other like step for doing this using Python or Matplotlib, it's absolutely fine. It doesn't matter the way you do it. But for others who didn't know anything, this is the most easiest way of doing it. So yeah. And Dhruv, what's the plan for lab 5?
I guess we can break to our respective groups. Then, if they have any specific doubts, they can.
Okay. I'm not sure like what do we have to check or something?
Yeah, we can ask them the progress of lab 5. Yeah, how many of you guys are done with part 1 and part 2? Can you just reply yes on the chat?
So have you guys started lab 5? Okay. So was lab 1 part 1 and part 2 given first or part 3? Also?
I think most of them have done part 1 and part 2. That's what they're replying on the chat.
So I guess some like everyone has done it partially, like lab 5. Like most of the people haven't done it completely. So I guess you can join the respective teams and like ask the doubts, but they will know. Like there is no checking today, like no evaluation. But you can ask the doubts, and maybe in the next lab you will have the evaluation thing.
Okay, then let's then do this. So we'll ask like in the next tutorial we will finish with lab 5 grading. So just
Yes.
so
So please like finish the lab 5 by next week.
yeah, so that's a hard deadline, and we're not going to extend on that. So you have to finish part 1, part 2, part 3 of lab 5 by next week. That's it.
Mostly it's not on OJ. Like we will see and tell you. So just
Yeah.
like keep your codes ready for evaluation. Now you can. Yeah.
Sir hasn't done pointers like completely yet, and lab 5 part 2 is pointers.
So that's why we said like I guess he will probably do in the next class. So apart from pointers portion, just do rest of the things.
Yeah.
And we will see the deadline. If we will think like if sir has not covered that thing, we will extend the deadline. Don't worry about that.
Yes. Thank you.
So
See,
yeah.
when I
Any other thing?
hello, can you guys hear me? Dhruv, can you hear me?
Yeah.
Yes.
You also.
So when I'm checking part 2 of lab 5, the pointer questions, they are very basic pointer questions. I think sir has introduced pointers, and that's all that you need to know.
So I finished lab 2.
Yeah, part 2 of lab 5.
Yes,
That-
I finished.
That's chapter 11. So the pointer operations are really basic there. You just have to, I mean, it's the most basic
Yes,
pointer.
sir.
Oh, okay then. I haven't seen them yet. So
It's nothing to do with arithmetic, nothing to do with pointer arithmetic, nothing to do with anything fancy with pointers. So it's very basic pointers. So I think sir has introduced pointers already, and that is enough for you to do. There are only 4 or 5 questions, I guess, in chapter 11 on pointers.
yeah, okay then, sir. Then yeah, fine.
Yeah, so that's why I try to finish it by next week. Otherwise,
And one thing more, lab 6 students in the Ishita ma'am's batch, like have to like join with me today. I don't think she will be able to take it. To join with lab 2, I will send the link to her maybe. So yeah. So that's pretty much it. You can join the respective batches.
yeah, let's do that. Yeah.
Thanks.